Teknoloji ve çevre bilincinin gün geçtikçe artması.
You know, the technology is developing and the renewable energy is needed more and more every day in the world. And wind power is in the renewable energy resources. And when we have it more evidently used in this perspective, we will have better results in terms of global warming. There are many studies and researches going on also in Turkey. And one of them is about the prototype turbine production Miller-S project. This is a project in Turkey. When it is going to be completed, it is going to have 2.5 megawatt turbine, which is locally manufactured. The first phase of this project, it is a 0.5 megawatt turbine. It was already over, and the tests are waited. After that, the erection studies will start. We will have presentations, then we will have your questions, and I have a really I need to ask the panelists to introduce themselves first. I would like to start with Stefan Philipp. You can make your presentation.
Okay, good afternoon. My name is Stefan Philipp. I'm a head of portfolio management at Senvion, being responsible as interface between the market on one hand side and the R&D organization in order to shape Senvion's product portfolio in order to come up with a competitive and solution-oriented portfolio. What I'm going to present today is giving you an overview of how we see the development of the wind turbine portfolio, not only today, but also giving you an outlook into the future. However, because Senvion doesn't show up in the recent publication on the statistics of wind energy in the Turkish market, I take the freedom of just summarizing in one slide what Senvion stands for. And actually, Senvion is a brand that exists only for 1 year so far, but the company exists for more than 14 years because we have been founded already in 2001, and at that point in time we were named Repower System. However, changed our name 1 year ago in order to give it a more fresh and vivid look. Our headquarters is in Germany, but even though we are spread globally with almost 20 offices worldwide. And we also have an office here in Turkey, which is in Ankara, in order to directly interact with our customers. The revenue in 2013-14, which is our business year, was 1.8 billion euros. And in all this time, we have been able to install 12 gigawatt of installations worldwide. So you see there's quite some competence in the company, which we're more than happy to bring also to Turkey. And I have to say, even though we're a German company, more than 60% of our installations are made outside of Germany. And the portfolio, as you will see, will range from onshore to offshore in varied configuration. However, before I actually start in going into the details of the portfolio, I would shortly share with you our vision of certain developments that we see in the market. And first of all is the development of the tariffs, the feed-in tariffs, the concept, the political frameworks. And basically what we have seen in the past is there was a strong need in order to stimulate renewable energy. And that was mainly driven and supported by installing feed-in tariffs, which were giving quite a predictability to the market members. And that was in particular driving in the past to further come up with new turbines, higher rating, higher rotor diameters. However, in some of the countries, this has already changed towards a more auction-based system, which means you don't have a PPA per country, but you decide project by project how much PPA you are going to give for the project. And we see that is going to happen from one country, from one region to another region. And that will ask for us as a turbine manufacturer as well as for our customers to further optimize the turbine or the wind farm project to address the project-specific needs. Where do we see the tomorrow? Tomorrow will most likely, and as we are all driving to reduce levelized cost of energy, we are going to participate with the wind farm projects in the conventional energy market, which means not only technically, but also commercially, which means the energy that we're producing with the wind farms is going to be traded on a daily basis at energy markets. And also for that we see some political frameworks being installed already, and we from the technology sides are implementing core technologies in order to allow multiple market members in order to facilitate those setups. However, the key point is going to be to reduce levelized cost of energy, because in all these initiatives and ambitions, this is the key point, and we want to gain grid parity. We have been able to do that in some cases, but we have to further strive for doing that. And there are different elements how you can reduce levelized cost of energies, but if you look at all the different components, the annual energy production is still the dominant element which is driving the reduction of levelized cost of energy. Second biggest element is the capex, the amount of capex, the cost of capital, OPEX, and there are other effects such as financing and others. So the question is, what can we do as a turbine manufacturer in order to address all those elements with the according priority? Of course, we are striving for an even further improved portfolio, bigger rotor diameters, higher rated power, but so by that renewing our portfolio constantly. But it's also about, as I was referring earlier to adopt the turbines or the wind farm projects to address the project-specific requirements, which could be specific grid requirements, specific sound requirements, or climatic conditions, such as very hot temperatures or very cold temperatures. To think about new transportation concepts in order to bring the even longer blades into the final site, but also to make sure that the portfolio that you're offering is appreciated by not only the customers, but also by all the other members of the business case, in particular the banks. However, it's not only about selling and installing turbines, it's also about operating turbines. So making sure the business case really works out for 20 years, and to have the corresponding means is one element where we as turbine manufacturer can support the further reduction of a levelized cost of energy. So how have we done in the past, and how do we basically measure that? So what you see here on the left-hand side is a typical onshore project and how the cost of such a typical onshore project over the entire lifetime splits among the different cost elements. So the biggest investment and the biggest portion is still the turbine, plus some optional products that you may need in order to adapt it to the specific projects. But you certainly have BOP cost, you have O&M cost, financing basically could reflect easily 25% of your projects. So if you take this as granted and as the yardstick, we have been able to continuously reduce the levelized cost of energy by introducing further turbines, by enhancing the cost of these turbines, and by further increasing the output of those turbines. Even though the levelized cost of energy clearly changes depending on the wind condition on your side, this basically reflects the trend that you can see how the portfolio supports the constant reduction of the levelized cost of energy over introducing new and further improved variants. However, what you see also at some point in time, you may not be able to further reduce cost further reduce the levelized cost of energy by even bigger rotors and even further cost out measurements. You have to make a major step, and this is what you see on the dotted line. You have to go and come to a new platform at one point in time in order to make a quantum leap. So this was one of the key developments and key observations. The second key observation is that renewables, and this is in particular also clear and important for the Turkish market, is becoming a very important element of the electrical supply of electricity. So while in the past renewable energies were a kind of alien in the electrical grid, so it was accepted to some extent, but when it became difficult in terms of grid stability, it simply had to step back. That changed, and with the increase of the amount of renewable energy, they have to play their role. So they have to be part of supporting grid stability. So we see quite challenging requirements and corresponding grid codes, as they are in Germany, Canada, and also in Australia. Well, if you look into the future, that becomes more and more dominating and pace-setting development that we see also in our portfolio. And one of the key developments that we see here in Europe is the consolidated and standardized requirements for wind turbines or for electricity, basically by the pan-European standard of NSOE, which is going to standardize the grid requirements for electricity over the entire European countryside. So as this is coming up, and as this is coming up pretty soon, so we expect the implementation end of 2016, beginning 2017, this is basically what we have to prepare for, and this is what we are going to prepare for. So, however, now let's come to a little bit to the bits and pieces. So what is the typical product portfolio for Senvion? So what you see here is our basic members of our portfolio. So we have a 2 megawatt platform, as well as we have a 3 megawatt platform. Both platforms support different wind conditions, basically strong wind, medium wind, and low wind configurations with big rotors, smaller rotors, and different rated power. So depending on your project condition, you certainly will find one of the other configurations supporting your projects. The question could be, why do we support 2 platforms, a 2 megawatt as well as a 3 megawatt platform? Basically, it again depends on the project conditions, whether you have an unlimited area where you can install as many turbines as you want, or whether you are restricted by your grid, or whether you have only limited area where you want to squeeze as much as possible energy out of your area, and you're not necessarily limited by the grid feed-in. So depending on that question, you may choose the one or the other platform. So how is this platform going to experience? So as said, we have experienced quite a bit over the last years with almost 12 gigawatt of installation. So by nature, the 2 megawatt platform is the bread and butter machine in our portfolio, out of which we have installed almost 9 gigawatt worldwide. So from a countryside, as said, we have been able to install more than 60% outside of Germany, mainly focusing on the European and the North American market. However, as you're in the process, potentially in the process of deciding for your wind turbine, certainly you will look at the performance figures of the brochure. But the question is, or let's say finally, what levelized cost of energy you are going to achieve clearly depends on the performance of your turbine in your wind farm. And while you certainly will make sure with corresponding contracts and guarantees that whenever you see and observe a deviation of the performance in your wind farm, you get corresponding compensation, you're still sitting, or you're left in a situation where you're not very happy, because you certainly made your business case based on different assumptions. So in order to bring the experience of our current customers to our new customers, we did an exercise. And in that exercise, basically, we were asking a third party to review all power curve measurements that we have been doing, either ourselves or our customer have been doing, in order to validate whatever we print in our brochures is what the customer really can see in the actual projects. We have done that not only in Germany, not only in Europe, but we have also measurement campaigns run in Northern America as well as in Australia. So by that we have been able to collect more than 40 measurement campaigns, spread over 6 countries. And as said, in order to make sure we are not cheating, we have asked a third party, and in that case it was GL Garrett Hassan that we were asking, in order to review the process of doing these measurement campaigns. Basically what we were looking at was A, do we do the measurement correctly, and B, are we cheating in the selection of the projects? And basically we did not do a selection at all, rather than we took all the measurements that we were doing. And what you can see is basically we were able to do measurement campaigns over the entire portfolio, that we have 2 megawatt as well as 3 megawatt turbines. And what we did is basically we compared the power output that you could derive out of the business case during the pure mass based on the paperwork that you get as customer. And we compared that output with the real measured output in those wind farms. And what you can see is basically that in all those measurement campaigns, we have been able to prove that the power curve of our turbines is really what the customer has experienced in his wind farm. So while some consultants and bankings are typically recommending to degrade or let's say to prepare for some risk provision in case the power curve is not met, we are capable of proving not only by corresponding guarantees but also by corresponding experiences by our customers that this is not necessary, rather than our customers experience that in the real projects. So this exercise is now a couple of years old, and we are in the middle of the process of renewing this exercise. And basically we have done that. The measurements are completed, and we have been able to double the number of measurements. So we moved that from 40 to 80 measurements that has been done. I mean, typically we would have loved to extend it even further, but the measurement campaigns are quite comprehensive. So we can't do that actually for each and every site. But we are more than happy that even with the 80 measurement campaigns that we have been doing, we could reconfirm the reliability of our power curves in the projects of our customers. So by that, we hope we are able to bring the experience of our current customers also to our new customers. However, what do we do on top of bringing good experience to our customers? We are further shaping our portfolio. And shaping in that sense means, in particular, we are further bringing new variants into the market. In particular, the 3 megawatt platform is further developed. And as you can see, we have been able, in particular, for the mid-speed turbine type, we have been able to further improve the power output of the turbine, not only by aerodynamic furniture that we are attaching to the blades, but also by finally increasing the rated power of our turbine. And by that, finally increasing the output by another 4.5% on average in the different wind projects. What else can we do? Certainly we can increase the portfolio in terms of different hub heights, because also you may experience that different projects may have different requirements in terms of maximum hub height that is applicable. So here we are further increasing our portfolio in order to come with different hub heights in the portfolio. And in particular, to mention here also the number of hub heights that had increased for our low wind speed turbine, the 3.0M, with 122 meter rotor diameter. However, what's coming up next? And here we are addressing the second trend that I was referring to, that we see the increasing requirements that we see for the integration of wind turbines into the grid, as we are talking about an increasing amount of renewable energies, and in particular the standardization activities in Europe. So we're in the process of introducing a so-called next electrical system. So we are renovating the electrical system of our turbines in order to address those increasing demands that we are seeing, which are currently discussed and in the process of being finalized. And basically we are going to come up with transferring the entire 3 megawatt platform to address those requirements with the new electrical system. What is the advantages of this electrical system? Basically, it will increase, as said, the electrical capabilities. So in particular, the fault ride-through capabilities of our turbines, whether it's over voltage ride-through or low voltage ride-through, will be significantly increased, quite substantially, which is quite important for the RISE market as well as for the Turkish markets. But also we extend the steady-state voltage range, but also the reactive power capability, which means the capability of the turbine to stabilize the electrical grid in order to support grid stability as it will be appreciated by grid operators. What is the timeline of introducing this new technology into the market? Basically, we are into the process of installing our very first prototype. This will be done again in Germany, but based on that, we are basically launching our initial series, which we are going to sell basically brought over Europe. Before then, the serial introduction will be beginning of next year. And as said, not only less than 12 months later, we are going to see these new requirements in the European market to be introduced and adopted in the individual national grid requirements. So by that, we expect to be prepared and prepare our customers as well for these new grid requirements coming up. However, another thing in terms of grid integration is also important, which is again supporting our customers and in supporting a setup which is capable of supporting direct marketing of electricity into the grid. Now you will argue what is the specifics of selling the electricity not only to utility but directly into the market, what is basically changing. And the specifics to this is that you basically are integrating a new stakeholder in your setup. While on the left-hand side you have the wind farm with your wind turbines, and which is typically owned by the wind farm owner. You have on the right-hand side now two entities. You have on the lower end side, you have the grid operator, so the company who is maintaining the stability of the grid. So whenever this company is supporting the feed-in of electricity, it will basically open up the door so that you can feed in your electricity into the grid. However, when grid stability is endangered, this is the entity which is clearly reducing the feed-in of electricity into the grid in order to make sure the grid stability is not collapsing. The new member into the setup is the company which is doing actually the sales of the electricity into the stock market. So this is the company who is deciding how much electricity is going to be forecasted and at which price this company is going to sell the electricity at the market. And as in some cases electricity certainly can have high prices or low prices, or in some cases even negative prices, this entity certainly also wants to control whether it is going to feed in the electricity into the grid, or whether it wants to refrain from supply electricity into the grid. Now what you can see is we're sketching a scenario where there are two entities which not necessarily have the same sequence and are not necessarily in synchronous when they want to feed in electricity into the grid or not. Which means we can come up with a situation where the one member, such as the grid direct marketer, wants to sell electricity into the grid, but the grid operator is stopping any further additional feed-in of electricity. And vice versa, the grid operator can open up the channels in order to feed in grid, but the direct marketer wants to stop it. So what you basically have is here a concurrent control mechanism, and this has to be supported by corresponding control mechanism in your wind farm, because this is the point where you will certainly want to control this. To make a long story short, this is where the sophisticated SCADA system of our company are very much developed in order to support even those more complex developments as we foresee them sooner or later to come in various markets. So, last but not least, if you think your project is a very complex one, difficult to solve, I just want to mention that Senvion is not only active in the onshore business, but also in the offshore business. So if you think the rotor diameters that you see currently in the onshore market is state of the art, I can reconfirm that offshore is not only in terms of project development, but also project implementation and the technology that you need there, because the project conditions are quite complex, are much more challenging for a wind turbine manufacturer. So we are more than happy that in various technological developments, offshore is paving the way for us as a company in order to develop new technologies, bigger rotor diameters, and we have also here been able to prove the reliability of those technologies by corresponding installations in the offshore world, so to say. So, by that I want to conclude my presentation and hopefully could give you, in the time given, a short overview of our company as well as our portfolio and what trends we see in order to come up further. So, if there is any question now, I'm more than... as I understand, we are going to have the question and answer session at the end, and I'm more than happy to answer those questions coming up. Thank you very much.
Stefan Bey'e yaptığı bilgilendirme sunumu için.
Thank you very much. The second speaker is from Siemens. We will listen to Gunnar Lear.
Yeah, good afternoon, ladies and gentlemen. Thank you very much for inviting us. It's a great pleasure to be here today. So therefore, my first picture is a picture of a Turkish wind farm, so you can see how beautiful such a wind farm can be. It's built with our direct drive turbines, and I will tell you a little bit more about how we see the market, what's next, and so how do we want to support also Turkey in further growth in wind onshore especially. So how does that go? Okay. So first of all, I mean, if we look to the Turkish market, it's a big success story. It was a journey we have been late, what we picked up over the last years. So therefore, it's amazing to see how the growth was here in Turkey, and it's also the growth which is still expected. So therefore, for us from Siemens, we are 160 years in Turkey, of course, with a number of things from our portfolio, and now also we have an onshore team here which is supporting the market in that growth. And for us, it's clearly one of our core markets of the future. Now, if we see where we have locations at the moment, and you see there we have installed so far 235 megawatts in operation, 98 turbines, and we have signed another 346 megawatt, which is under construction. So we can say we understand the Turkish market, we understand the customers, and so I think it's a very attractive business. It's an attractive wind conditions, which are also very nicely fitting to our portfolio. So therefore, we want to do more. So whoever sits in this room and says, okay, I would like to do more, let's talk. Let's talk about more wind farms here in Turkey. Now, Siemens Wind Power, as it's one of the divisions, of course, we can do more. So that means Wind Power and Renewables division is representing the renewables portfolio, which is wind on and offshore and small hydro activities, but the majority of that is wind power. So we are happy to be one of the leading suppliers in that range. We also were able to keep the #1 position in 2014. 2,000 turbines, 5 gigawatt, which is impressive, so to see. Our organization, you know, was started by an acquisition. This acquisition from Bonus was seen as one of the most successful ones within Siemens. As we started, it was 2004, which is not that far away. That organization had roughly 700 people, 250 million in revenue, and now we've grown up to that size, which is a quite impressive number. So if we see where we are right now, we are a clear global player. So that means we have a focus on the American market, and we serve the North American market and also the Southern American market out of Orlando, where is our headquarters. We have also production capacities there for the European part of the business. We are coming mainly out of Denmark and Germany, where the global headquarters is. And for the Asian market, we have in China also a joint venture here to serve that market. Of course, further growth also means further commitment to more markets to come, and also the topic of localization, which is a key topic, and I guess we will talk more about that one in the upcoming question and answer session, is something which we have in our agenda. So therefore, of course, whenever we think about new markets and an intensive and stable pipeline, we also make commitments to these markets in regard of localization. But that is the current status we have, and we have in our agenda more to come also for Turkey. Now, if we see the platforms we are driving, that is the portfolio. We started with our G2 and D3. G2 stands for gear turbines, and D3 stands for direct drive 3 megawatt platforms. So you can see it already started in 2009, where we introduced that new concept. And over the meantime, a number of new variations, but always based on that platform concept. And that is one of our principles we follow, is having a platform and then playing with the components so that you always can come up to turbines which are fitting to the needs. So now the current one, what we also selling to our Turkish customers is now for IC2A markets is the 3.213. And now what we also will bring up in the next weeks to come is an upgrade for our 3.2 to a 3.4, 108, IC1, and 101 also for IC1. And then the next level, which we introduce from 17 on. So now we built this year the prototype, we install it, we do all the measurements, we all this. So from late 16 on, we come up with our new 3.3, 130 meter. It's also an IC2 machine. So meaning normally rotors of that size are IC3. So we have it as an IC2, meaning this machine can also compete with IC3 machines, but there's more to come. So that means on that platform basis, we then also can further develop it to a real IC3. There are a number of innovations in these concepts. Of course, one is our generator concept. The next one is in our blades. So we do these integral blades, which is a special one also from our side. We have different tower solutions. Here in Turkey, we mainly sell tubular steel towers, but in other places in the world, we have for this portfolio also hybrid solutions for high tower solutions. We have the integrated converter solution, which is something what also comes from the family. So we make use of what is already existing within Siemens, also to use that in our turbines. So the direct drive turbine is an electrical machine versus a geared machine is more a mechanical solution. So, and we are doing this, and we're also investing heavily in automation of our production facilities, for example, for the blades. Now, if we see the D3, the direct turbine, we have already installed 1.2 gigawatts. So some customers say, okay, how much have you done already with this one? You see here, it's quite an impressive track record already on that platform. And 2.4 gigawatts we have under construction or orders on hand already. So therefore, that can be seen as a proven solution. It was the first generation of a direct drive turbine. By the way, Siemens has also a direct drive turbine for 6 megawatt, which is for offshore. So you also can see there are some synergies from the engineering point of view, so that we also can scale these solutions up between on and offshore and make use of what we have in the organization. So the same happens with the blade, for example, and so on. So therefore, there is some added value if you have on and offshore here. Now, what's next? Next, that is also our turbine for Turkey. Our turbine, the future turbine for Turkey, is the 3.330, which is based on that platform. It's platform version 2, let's say. We have higher output for medium and low wind speeds. It's an average increase of the annual energy production of 14 to 20%. And it has also, of course, a comprehensive tower program. And the towers are produced in Turkey, which is important here for the local market. So we have here established partnerships to support this one as well. Now, if we look to that machine, as said, it's a 2A. Yeah, it's 130 meters in diameter, and the prototype is planned now. Pilot series start in 16, and then full available end of 16. So that we then also can support your interest. And again, it's an IC2 machine with such a rotor. I think you will not see another IC2 machine with such a rotor, and it also can compete with an IC3 machine. So think about it, and you will find out how attractive it might be. That's it. That's my last picture, also from a Turkish project. So again, a very nice picture. I would like to do more of it. So my Turkish team and myself, we are there to support and would like to do more of this. Thank you very much.
Ömer Bey'e çok teşekkür ediyoruz.
Thank you very much. The third speaker is Mr. Lars Moller.
Hello, merhaba arkadaşlar. For those of you who speak Turkish, I don't, except that. I'm Lars Moller. I'm the Senior Vice President at TPI Composites. We are a wind-based wind blade manufacturing based in the USA. I'll give you a bit of an introduction to us. Some folks know us. We supply blades to wind turbine manufacturers. We're not a wind turbine manufacturer, but we are a built-to-print wind blade supplier. We're based in 3 continents, North America, of course, also where we have our headquarters in Scottsdale in Arizona. We are in Europe, and then we are in Asia as well. We're in the top 3. It's a little difficult to measure who is the biggest. We prefer to say we are at least the highest quality, but at least being the top 3 is part of our strategy. Worldwide, we're 4,000 employees. and we have under roof roughly 200,000 square meters. We have roughly 4 times that if you include the property that we sit on, so roughly 1 million square meters of land. These are our locations. As I said, we're in Scottsdale with our headquarters. Apropos Turkey, we have a very large facility down in Izmir. We have 1,100 folks. We'll talk a little bit about that here in a minute. But we founded 40 years ago, roughly, actually started building boats and created our own patented infusion technology, infusing the resin into the fiberglass, which is somewhat unique. We transferred that roughly 15 years ago, where we started making our own blades, our first blades, roughly 13, 14 years ago. We moved to Mexico. We then 8 years ago moved to China. We have 2 on the map, but actually 3 facilities now. We're commissioning our 3rd facility in China as we speak. 2 smaller R&D centers up in Fall River, Massachusetts, and in Warren, Rhode Island, the northeast part of the U.S. So give you a little bit of volumes. You divide it by 3, then you have the quantity of wind turbines. 6,500 wind turbines we made blades for roughly 1.5 to 2 megawatt average. So quite a bit of megawatts of wind turbines out in the world operating with TPI blades. We are, as I said, a build to print. We are unique in that we do not design our own airfoil structural things. We are a manufacturing production expert. So we help our clients, the turbine manufacturers, to develop the manufacturing process. So it's optimal for serial production, the supply chain, the local supply chain, not just global, but also the local. We are unique in another way in that we actually manufacture our own molds. So whether that's the shells, the spar cap, the girder, the larger components inside of a blade, we actually manufacture the molds ourselves, both in the US as well as in China. We sell those molds both to ourselves, we actually sell them to our customers. Some of our customers make blades themselves, and we actually sell molds to them. And in fact, we also sell our molds to competitors. So it's part of the strategy to do that. Of course, like everybody, have laser tracking equipment to make sure that we have precise molds and blades. One thing we do when we go out and not only sell, but when we go out in countries like Turkey and build a facility is we, as I said earlier, really start developing the local content. So whether that is a carbon requirement in some of our customers' equipment, whether that is resin, the different kinds of fibers, we not only help the manufacturer on optimizing the production, but we also go out and help localize some of the fibers. That cuts down the working capital requirement inevitably to help lower the cost of energy, but also helps in terms of deployment, time to market, things of this nature. So this is a piece of what we do, actually quite global, but also have a large staff on our supply side here for Turkey in particular. We have 10 employees. That's pretty much what they spend their time on, making sure we can start buying the same fibers we buy in China, the US, Germany, wherever it comes from, that we can actually localize and transfer the technology of raw material to places like Turkey. This is the Pride and Joy in Izmir. 25,000 square meters on the roof. It's out in Sassali, northwest of Izmir. What can I say? We run 6 molds. 6 molds of this facility produces a little bit more than 1,000 blades a year, about 1,100 blades. You see some of them stored outside. Our customers ask us to serial produce, but launch and ship out as the projects get constructed. So every blade facility we have has quite a bit of a storage capacity such that we can have serial production, but also launch in time, just in time as the clients require. But a beautiful facility that we converted here over the last 3 years. So we've been in Izmir 3 years, and as I said, have a little bit more than 1,000 folks. This is a photo of some of the teams, the team members, quite a bit of engineering We're heavy engineering quality folks. Of the roughly 1,100, more than 200 of them are related to quality and engineering alone. So this is very manually intensive work. We don't have robots. This is every piece of fiber is laid by hand. So not only do we do a lot of training as part of onboarding people, regardless what country, China, Turkey, US, Mexico, that we go to, but we obviously also make sure that it's built to quality and to the specifications. You guys know the environment. Surely the folks sitting up here know the environment where they sell their turbines. The blades we manufacture through their specs must withstand the IEC 1s, the IEC 2s, et cetera, et cetera. So heavy on engineering and heavy on quality control. We're ISO certified, like most people need to be in our sector. We're adding 14,000 in the next 12 months, and then also a safety standard, OSIS 18,000 in the next 12 months. So in summary, global footprint, we're expanding. Strong growth rates inside the family. We produce the blades for the OEMs. You can look at statistics here yourself. Okay, teşekkür ederiz. Thank you.
Lars Bey'e biz de çok teşekkür ediyoruz.
Thank you very much. Also, the production, I mean the equipment produced in Turkey, you know, we are giving a support from our general directorate. And also there are some wind power plants, and we see their number is increasing using those blades. Last speaker is Maria Sangros. The floor is yours.
Thank you. I think we don't have the speakers, right? We don't have speakers. No? So, thank you very much. My name is Marios Zangas. I am the technology manager for Vestas for Turkey, Greece and the Middle East. And today I'm going to do a run-through of our products and our technology development. And I'm going to start by a brief introduction of Vestas. It's just a single slide to let you know that we are a company which employs approximately 20,000 people. We are monitoring approximately 28,000 turbines which are installed around the world, a cumulative installed base of 66 gigawatts. And approximately 7 billion of revenue for 2014. So my agenda for today is to speak a little bit about levelized cost of energy again, update you on our products, talk a little bit about the fundamentals of how we develop our product roadmap. And I'm going to finish up with the options, the ancillary offerings and services that we offer. I have a separate section for levelized cost of energy because this is all we talk about in Vestas. And allow me to very briefly remind that the levelized cost of energy is a fraction of the total cost of your project over your annual energy production over the lifetime of the project. So some of the procurement guys might not be very happy with what I'm going to say, but the wind turbine price is not what affects cost of energy the most. What affects cost of energy the most is the annual energy production. And us, as manufacturers, we are doing our best to increase the annual energy production in every single way possible. So as you can see from this graph, the effect of the turbine reduction versus the annual energy production increase in a given project gives a clear winner on the AEP. Our focus is to increase AEP, therefore decrease the levelized cost of energy, and at the end of the day, help our customers increase the IRR of their projects. Moving on very quickly to a product update. Vestas currently is offering two platforms, the 2 megawatt platform and the 3 megawatt platform. The 2 megawatt platform was introduced back in 1995. We have many units installed globally. We have a lot of experience in many different wind regimes, many different climatic conditions, extremely high temperatures, extremely low temperatures, low, high altitude, you name it. The 2 megawatt platform has been there. The 3 megawatt platform introduced in 2012. This is our new 3 megawatt platform. The old one was the V93. Currently we have more than 1,800 units installed. And it is a platform that we are proud that it is one of the most extensively tested platforms in the wind industry before it was launched back in 2012 in our aging facilities in Aarhus in Denmark. So the 3 megawatt platform was originally born as a 3 megawatt turbine with 112 meters of rotor. We have 1,000 turbines of this kind installed. And a couple of years ago, we evolved this first generation to a family of products, the V112 3.3, the V117 3.3, and the V126 3.3. The 117 3.3 is comprised with a blade which is a root extension of the one that we used on the 112, and the 126 has a blade which is a new design which is called structural cell. On the 2 megawatt platform, we went through some mark revisions since the launch of this platform, the new 2 megawatt platform, where we introduced the V100. We included a permanent magnet generator and a full-scale converter. We did some changes in the gearbox. All that led to the mark revision 10, which we are currently offering in the market. Which is a V100 and a V110 on 2 megawatts rated power, of which specific MAR version we have approximately 150 units running, mainly in the United States, which is a huge market for the 2 megawatt. Overall, the 2 megawatt installed globally are approximately 20 gigawatts. Now, this is a slide we take particular pride of. The figure that you see in this axis is LPF, which stands for lost production factor. In a very simple way, lost production factor is the energy that a given wind site is producing versus the energy that it could be producing should it have no faults or no downtime whatsoever. So you can see that the blue line represents the lost production factor of approximately 18,000 turbines that we are monitoring around the world. The lost production factor that we have now in our fleet is close to 1.8%. So that means that in a monitored fleet of approximately 18,000 turbines, we are losing less than 2% of the available energy which is there to capture. Another important fact about this figure is that the lost production factor is continuing to drop as the global installations increase. And that, in our eyes, is a proof of not only producing and servicing good turbines, it's also proof of quality standards that remain throughout the manufacturing process of the turbines. Moving on to the fundamentals of Vestas product development, as I have said, we are focused very much on levelized cost of energy. We are focused a lot on two global platforms. We have the 2 megawatt and the 3 megawatt, which we are trying to develop and further push to their limits as much as possible. And we have two other things in mind when we are designing our product strategy. The first being a product which is as flexible as possible and as adaptable as possible to your site-specific needs. And finally, a product that can offer options and enablers that can improve your business case on your specific site needs. A few more words on increasing the flexibility of the products. You might know that most of the manufacturers are producing turbines that can, at the end of the day, be certified by a third party, usually DNV. So there is a specific envelope of operation that we are certifying against, which is dictated by IEC 61400. In a very simplistic way, I can show you that what we are certifying for is the red line that you can see in this graph. The question is why we don't take advantage of the rest of the area in this graph, where you can see that all these blue dots are actual wind farms, which are not on top of this red line, which is the 100% utilization of the turbine design. So the question is why we cannot use a wind farm which has been certified for a specific turbulence with even higher turbulence than the certified one, if the site conditions permit it to be used like that. Or in another way, why not use a turbine with a higher wind speed than the one certified if the turbulence in the specific site is lower than the one certified? This is a very simplistic example to show you that unless you have the possibility to install your products in the most flexible way in a certain wind farm, and unless you have the ability to push your products as much to the limit as possible, you are losing a big chunk of the business case that you could have readily available in your hands. So overall, our focus is to use all the variables of the product in order to utilize as much as possible of the specific site. It doesn't make sense to have a product that has the best reactive power capability in the world if you install it in a country where they don't care about reactive capability. And why not install a product with very limited reactive power capability if you can take the excess load capability of the turbine and increase the active power, which will increase the production of the wind farm. So all these factors are taken into account in order to have as flexible product as possible for your business case. Last part of my presentation, the options that we are offering, and I'm going to start with the towers. We obviously have a standard portfolio of towers, but the one that I would like to focus more on is this second slide, which shows the focus of our company in towers which are turbulence specific. So A, B, and C turbulence. Actual project statistics show that it is a very small percentage of A turbulence sites that are still in the market, and a very large percentage of B and C turbulence right now. So the question in maximizing, again, your business case and improving the levelized cost of energy is why not use B and C turbulence specific towers that could be cheaper and could improve the business case. On towers, again, we have the offering of the high altitude towers. We go high by splitting the bottom section of the tower in a manner like you can see in this picture. We call this concept a large diameter steel tower. It obviously has the advantage of being easily transported compared to a traditional tower concept which has no bolted connection. Overall, our tower offerings are tabular steel, large diameter steel tower, hybrid tower, and concrete tower. Moving from left to the right, we're talking about most mature and high volume in the market technologies to less mature and less volume of actual projects. But all of these concepts are available from Vestas. As far as noise is concerned, Also, it is an area that a lot of winnings can be found for the business case. Aerodynamic features that we are introducing in our blades. They are called serrations. It's an aerodynamic add-on that can reduce the noise level of the wind turbines. And also operational strategy optimization via tip speed changes that can ensure lower noise for noise-sensitive areas. De-icing offering, that's a nice graph at the left. Some of you might recognize that this is a power curve. You have many outliers in this power curve. These are due to ice. This is a real life example, by the way. And de-icing, which is an offering also from Vestas, moves these outliers back to the power curve. How exactly does the de-icing system of Vestas work? We install a heater and a blower at the root of the blade, and we are doing targeted de-icing in the areas of the blade where it matters the most. It is a system which draws a lot of energy, of course, because you need power to melt the ice of the blades. So it is very important to be able to detect in a correct way when there is an actual possibility to have gains after de-icing. So our system can only activate the de-icing system when, first of all, there is ice, of course, and second of all, when the actual stopping of the turbine, de-icing of blades, and restarting the turbine, with the consumption of electrical energy that this goes together with, makes business sense for our customers. Our de-icing system has no impact on the turbine. It's fully integrated, and since it does not utilize any metal strips on the blades, it does not affect the lightning protection of the turbine either. This has been the end of my presentation. Thank you very much, and I guess we'll take questions now. Thank you.
Arias Bey'e de çok teşekkür ediyorum.
Thank you very much. Thank you very much for all the speakers, and you also used the time effectively. Now it's time for your questions. No question? Then thank you very much. There's going to be actually a certificate to be given to all the panelists.